So happy Monday, October 27th, geometry. Hopefully the practice test that you guys were doing in my absence went pretty well. In this video, I'm just going to go ahead and work through the key fairly quickly so that you guys have time to work it in class and check your answers to see how you are prepared for tomorrow, but hopefully also answer some questions as we go through this. So the only thing I don't like is that I have to do this on Microsoft Word. Which means it's a little bit harder for me to like draw straight lines and stuff, but we will survive. So we'll go a little bolder, we'll go a little brighter, we'll use this lovely red color, and let's check it out. So for problem one, we are asked to graph the following figure and its image, and we need to represent our ending with this lovely function or mapping notation on this side. Now, to get rolling with this, I'm just going to go fairly quick through actually graphing the original pre-image. So we'll go out to the point 2, -4, 1, 2, 3, 4. Here it is, and there is A. And on B, we'll go to 4, 1, 2, 3, 4, -6, 5, 6. I believe that's 6. And we'll say, look, there's B. And C is the point 7, so 4, 5, 6, 7, and -3, 1, 2, 3. Here is our lovely point C. I'll make that one a little bit nicer here. Let's see if it kept it. It did not. So we'll go ahead and roll with it. So here's point C. And then finally, D is the point 5, -1, 1, 2, 3, 4, 5 in the X direction, and -1, and there is D. Now, without a straight edge, it's not going to be perfect, but I'm going to pretend like I've drawn a nice, perfect foregon, and here it is. Now, if we're reflecting over the line y equals x, this one has shown up a couple times, nowhere near as frequently as the x-axis or the y-axis. But if you're struggling with this, I would indicate to you the top of page 112 is where you would like to look to be able to make sure you get these rules for reflections. Now, if we reflect over the line y equals x, super easy. All that we have to do is swap these points. So meaning that on this A prime, if we swap x and y, and I'll just go ahead and show that, x comma y, if we go over the line y equals x, it becomes y comma x. That is the rule. So looking at this, pretty chill, -4, 2. B prime, if we just swap them around, should be -6, 4. C prime is -3, 7. And D prime is -1, 5. All right, so just so we can make sure that we see the clear distinction, I'm going to go ahead and plot these, and I'm going to use a little editing magic for you to check against yours. And with that, here is what we wind up getting for the pre-image here and the image over here. And then just to convince you, not that I think you necessarily need convincing of this, but I will sketch really roughly this line that we just reflected over, the line y equals x, as best I can because I don't have a straight edge. Should run right through here. And if I look, I can see that these things are at least kind of believably translated. Cool. There we are. All right. On number 2, we are looking at the same page here. If you're struggling with this, this is on the top of page 137 for the review or summary of section 1. If we are rotating it is not page 137, that's my mistake. But if we are rotating, and I'm just going to get the page lined up for us here in case it is helpful in our notes, that is on 3.3. So I'll go ahead and just kick forward to 3.3. And on the top of, it seems, page 128 is where you would find this if you are struggling with things. So we'll get off the eraser, we'll click here, we'll change the thickness back to what it should be, and let's dive in. So if we are on top of page 128, on the very top left, you will see that there are some lovely rules. So we are going to use function or mapping notation. And if I go 180 degrees about the origin, which is what we're doing, there is a super nice way that this works. We just change the signs on each of these. So m prime should be 2, -2. N prime, November, should be 0 because it would be -0, but we're not going to change that. And a +2, and P prime would be -1, 0. Again, if you want to write -0, you're welcome to, but it is not necessary. All right, now I'm going to zoom in a little bit. this is still number 2, just so that we can see this, but I was writing a little bit larger than I needed to. If we are going 90 degrees, the rule that we have, they swap places and their new front changes. So that means that here, D prime, if they switch places, it's here, 2, 1, and then whatever the new x coordinate is, in case here it's 2, we just switch a sign. So it was positive, now it's negative. On golf, G prime here, we see the same thing. We are going to go 90 degrees about the origin. They swap places, so it would be 3, 2, but that front point changes sign now. Okay, and the last one, F, Foxtrot prime. Swap places, here it is, 3, 1, and we make it a negative, and we have it. Cool. For these, each of these would likely be worth 2 points, half a point for each prime value, and then a half a point for trying. Cool. Probably didn't need to leave you as much space there, but that's okay. All right. On number 3, we are going to reflect and rotate a figure. So here we are looking at it. I have CD that lives at the point 3, 2, 3, 2. Here is C, 3, 2. And D is the point 1, 4, which looks like it's about here. Delta is 1, 4. And we'll just go ahead and make it a segment. Here's segment CD. Now, if we have to reflect about the origin, or sorry, reflect about the line y equals x, it is going to happen to be that same rule that we saw earlier. So here is C and D, and I'm just going to add this nice mapping notation. We have C at the point 3, 2, and D living at 1, 4. And the first thing that we're going to do is reflect. So we'll use R, and it's y equals x. Now, for the line y equals x, again, remember we have a nice handy rule, and I'm trying to find the page to make sure I can reference it. But if we are reflecting, we simply need to use those rules that are on top of page 112 is where we're at. So if I see the point 3, 2, and I want to reflect it over the line y equals x, these guys just swap. Now I'm going to call this one or change this one to a different color because this is just our middle step. We could call it C prime, and I really have no issue with that. But all we have to do is graph each figure and the image. So the C prime will never show up on our graph, but that's okay. So X and Y just switch places. So we get 2, 3, and D prime looks like it should be 4, 1. And if we go one step further, and we now need to rotate 270 degrees about the origin. So if we're rotating R270, just as a quick recall here, 270 degrees, we go from AB, or XY. I'm going to use AB because it's easier to not get goofed up. AB will map to, they swap places, so it's BA. However, the sign on the second one changes because it's just another application of our 90 degrees. So here we are, they swap, and the second sign changes, which means in our final little piece here, I'm going to switch back to my red color. I'm just going to call these prime again, purely because when we did the first one, this is really just my intermediate step in the middle. So I guess whatever, we can call it C double prime, that's cool with me. So we swap places, 3, 2, and then the negative goes on the second one. So again, D double prime here, they swap places. Looks like it should be back to 1, 4. And the second sign will change. Cool. All right. So we have these values and they're here. Awesome. Everything is answered here. On this, we would get a point for sketching the graph. We would get a point for finding this intermediate step, and we would get a point for finding these. And the last little point comes from us actually plotting this. So here we go. I'll switch color so it stands out a little bit more. We'll go this lovely green, bright green color. And let's see, C double prime is 3, -2. So here's C double prime in our case, and D double prime is 1, -4. Looks like it's down here. And if we look at this, it certainly is going to be what we're expecting. The first is a translation, or a reflection rather, across this line. So stuff winds up here, and then it rotates 3/4 of the way around a circle, or 270 degrees, and we get it. So our fourth point would come from not only graphing CD, but graphing C prime or C double prime, D double prime. All right. For this problem, we are simply asked to state whether each figure has line symmetry or reflectional symmetry. If so, sketch all the lines and say how many. So this one, yes, certainly has some line symmetry. I'm going to try to sketch them out, and it's not going to be perfect, but I believe that if we went to the midpoint here, we'd be okay, and the midpoint here, we would be okay. Now you're going to be tempted to try to do these other diagonals, but remember, because these sides are different length, it won't land on itself. So 1 point for sketching these two lines, 1 point for saying yes, and then there are only 2 lines of symmetry. All right. On B, so there's 3 points on this problem if we wanted them. For this problem, yours is black and white, so we're not going to pay as much attention to the color, but we also should see some line symmetry in here. Here we go. This first one is straight across. The next straight down. If we fold over on ourselves, it'll map. We have a third right here, and we have a fourth here. So as we look at these, the coloring would matter if you guys had, colored versions of this. The common mistake that people make here is if we have all these lines, yes, somebody inevitably is going to try to count 8 lines because you're going to double count. But remember, it's 1, 2, 3, and 4 lines of symmetry, which total coincidence that this dash in the middle happens to look like a 4. We'll just say 4 lines. All right. On number 5, we see that we are looking at each figure and we're trying to determine if there is rotational symmetry. If yes, awesome. If so, we're going to provide the magnitude, which is a new vocab that I'm sneaking in here, but it is just the smallest rotation for which the figure lands on itself. Now, looking at this one, what I see is we see symmetry across all of these. And if I wanted to take this point and go counterclockwise to get it here, that is a quarter circle. So we'll just say, yes, it does have rotational or point symmetry. And then all that we need to do is just say 90 degrees. Okay, nothing crazy. On Bravo, this one, it's not perfect, but that's okay. As we're looking at this, remember we agreed in class that we were just going to simply state no if it only has a 360-degree rotation. There's nothing that I can do to get this one to land on itself other than spinning full circle, so we'll just say no. Excellent. All right, this number 6, as we're looking at it, we need to rotate 90 degrees about the origin, or sorry, we are rotating this triangle 90 degrees about the point 2, 3. So we have this picture given. On the test, I would specify very, very clearly if I want you to graph it. I do think it's reasonable that with a graph showing, maybe one would naturally just want to graph this. But let's look at it here. So I'm going to plot these 3 points, A, B, and C, and P, 4 points rather, with a little editing magic here. And you are likely laughing because I can't draw straight lines on this program. Not nicely anyway. But we should get this little tiny triangle showing up. And it's kind of tough to see. If you wanted it to be a little bit nicer for a picture, an easy fix would be to, instead of each tick representing a change of 1, we could change that scale so that maybe 2 ticks is 1 and it would be a little bit more clear to see. However, as we're looking at this, the important part is that we are no longer rotating about the origin. So what we want to do, remember, to be able to get this about that point is we're going to move everything to the origin. And I see that to do that, I need to move this point P, which happens to be the same as A, and I actually misspoke, so a little bit more editing magic and I'll fix that. And I didn't notice it until just now. Unfortunately, I can't edit these, so here's a little quick edit to make sure that I get point A correct. And sorry about that. I looked up and when I saw A, I read this point and graphed it incorrectly. But now we have the right figure. So we're going to rotate this thing 90 degrees about point P right here. And in order to do so, we need to first move everything. And what I see is that point P needs to move 2 to the left and 3 down. So what I'll do is I'll move everything 2 to the left, so -2 in the x direction, and 3 down, and we'll wind up at this intermediate step here. And I'm not going to label A prime or anything, just so that I can end with a prime. But when I move this, I simply add this to the x and -2 to the x and -3 to the y. So it looks like we should get the point 2, 2, 2 left and 3 down. And B looks like it would become the point, and I said I wasn't going to put A and B, so I'll actually get rid of those. B would have become the point, let's see, 2 left gets us to 3, and 3 down gets us to -1. And point C, if we go 2 left and 3 down, will take us to 5, -1. Now, all of this was just to get us to the origin. Now, once we're here, we can go ahead and rotate our lovely 90 degrees. So using our rotate 90 degrees, and our rule, remember, AB just maps A comma B, will simply map to BA, where we change the sign on that front term. So we'll do that. And here we are. Looking at this, if we switch these points to 2, so here I'll switch them around, 2, 2, and you can't even tell. And then I change the sign of the first. So same thing, we'll flip these around. It's going to be -1, 3. But because I'm just going to switch it, -1, the opposite would be a positive. And same thing's going to happen here. We wind up at the point 1, 5. And all we're doing is swapping these, A and B, and then changing the sign on the front. Now, we have gone through the process of rotating this thing 90 degrees about the origin. We had to move it first, so our very, very last step of this would be to move it back. If we moved everything left 2 originally, we'll undo that by moving right 2. And instead of down 3, we'll undo it by going up 3, and we'll be at our final point. And it looks like if we do this, we're finally at our place where we're going to say A prime, and it looks like we'll add 2, we'll get a 0. We'll add 3 to the y, and we'll get a 5. All I'm doing is adding 2 to this and 3 to this every time. So similarly, point B prime, our final image, looks like if we add 2, it becomes 3, and if we add 3, it becomes 6. And on C prime, very last step, add 2, 3, and add 3 to the 5, and we get 8. And we now have our lovely, wonderful rotation about a specific point. All right. Now, little editing magic just to check again one more time. And when we look at this point here, now that I have it, it's in yellow. What we can see, I hope, is that this point A did indeed rotate 90 degrees. This point C went 90 degrees about point P, and this point B went 90 degrees. And it does indeed appear to be a rotation by 90 degrees. If you wanted to verify that, some of the tracing paper on your desk might help. But remember, even if you use tracing paper, I do want to see the actual mathematics and the mapping that goes on. All right, so the very last one clearly has a typo, but I've already printed it. So suppose that, and we're just going to cross that out here. Suppose that a point undergoes a rigid motion by composing 2 reflections. So if we wanted to look at this and write each of the following as a single rigid motion, there are a couple theorems that we've seen that will address exactly this. If we reflect a point, or multiple points, but we'll just work with a point, over 2 lines that are parallel, in the end, it'll look simply like a translation that is twice the distance between the lines. So it's a translation by 6 centimeters. And I know that we don't have a vector here. It's because we don't know exactly where that line is. And I'm just going to say 6 centimeters perpendicular to the lines. Now, if all you gave me was a translation of 6 centimeters, I would still give you credit, but it is nice to see that, yep, it's going to be perpendicular to those 2 lines. Okay, on part B, if we have 2 lines that happen to be intersecting with a 30-degree angle formed between them, and I'm going to sketch this situation while we don't have to, it might help to look at that theorem. 30 degrees between them, and here's our point. We're going to wind up getting our point here and then here, and what it winds up looking like is instead, if this is our center, we get this angle between those points. Here's A and A prime if we wanted to envision that. And it turns out that all this is rotation by twice this. So we'll say that's 60 degrees, and we'll say intersect. It's about their intersection is all that I mean by that. So hopefully you found this helpful. What I would encourage you to do tonight is make sure that you are studying. This practice test is pretty similar to what I'll ask you guys to do on the test. And I would use all of this good stuff here to help guide your creation of your note card to ensure that all of our shortcuts are there. And with that said, I'll see you guys not tomorrow because I'm also out tomorrow while you guys are testing. But if you have questions, feel free to shoot me an email. I will be around in the morning, and I can try to be around at lunch as well if needed. But let me know, stay in contact, and hopefully everything goes well. I will see you guys back in class on Wednesday where we will debrief. Swimmers, good luck, and we'll see you then.